Hi, what we're going to do today is we're going to look at the value of x. We're going to find the length of the secant lines that are exterior to the circle. Well, let's look at what we had, and it's the same proof, the same process that we've been using before. Let's look at this angle and this. I can say this angle right here, it happens to be equal to this angle. And if we look at it, this angle is equal to itself by reflexive postulate. Well, if that's the case, what we can say is this angle right here happens to be equal to this angle. We didn't know anything about the triangles. Well, let's look at the two triangles that I'm really working with in this stage. I'm working with this triangle right here. And I'm going to be working with this triangle right here. So let's give it letters, just for the sake of doing that. A, B, C, and we'll call this D and E. So I'm going to look at triangle ABC and triangle DBE. And if that's the case, let me redraw it. Oops. Sorry about that. Since you can tell these are two triangles, let me draw it in that way. And if we have this as angle C on one of them and angle E on the other, and of course B will be on both of them, so A and D. And angle D is written by a single, and B is your reflexive, and C is your other angle, C and E. And let's look at what we have. We're going to work with AB. The length of AB happens to be x plus 3. BE happens to be 3. BD happens to be 4 plus 5, which is 9. And let's look at a proportion that we can set up right now. And if you remember how I wrote it before, okay, in this case, we're going to do opposite to 1 over opposite to 2. Again, just for consistency and teaching purposes. If you want to go through these little steps, go for it. If not, and you can see it faster, that's okay also. Okay, opposite to 1 is a 9. BC, let me make sure. BC was 4. I didn't label it. So opposite the single is a 4. Opposite the double is an x plus 3. Opposite the single was a 3. Opposite the double was a 9. So let's look what we have. We can turn around and say 4 times 9 is equal to 3 times x plus 3. So 36 is equal to 3x plus 9. 3x equal 27. X equal 9. So let's go back to our original picture. If that's the case, this piece is equal to 9. Let's see if there's a way we can figure out a rule. Well, I did notice that this piece times this whole thing is equal to this piece times this whole thing. But let's not take my word for it. Let's just go through the process one more time. And with that, we're going to erase. And we're going to start from scratch, and we're going to look at the whole process all over again, but this time using letters. call this A, B, C, D. We know this is equal to this, and we know this is equal to this. And we're going to look at the two triangles all over again in the same exact way we just did it. Okay, opposite the one was a C, opposite the 2 was AB, A plus B. Opposite the 2 in this case was C plus D, and opposite the 1 was a B. Now if I set up the same proportion, opposite the 1 is a C over A plus B is equal to B over C plus D. And again, if I work on this cross multiplication, I will end up with C times C plus D is equal to B times A plus B. So it is what we said earlier, that we're multiplying this times that whole thing, which is equal to this times this whole thing, that whole side. And now we can practice a couple of these if you want. Okay?